Now, going on to the last section of Chapter 6 that we cover, it's Section 6, Introduction to Functions and Function Notation. Now, these are the objectives. You can pause here if you like. And it's even getting into the graphing calculator again. We'll at least show you, because I know some of you may have your graphing calculators, TI-83, TI-84s. And what is a function? And I'm going to use the text a lot here. The ordered pair discussed in the text, that is the x and y, are a good example of what we call a relation. Now, other relations is a key word in the area of function, is child and mother, a city and state, a name of a ball player and its batting average. These are all related, as is the ordered pair. One of the reasons this topic is included in this chapter is the ordered pair. Now, another set of words here is domain and range. Now, we've defined relation as any two things connected, and the ordered pair is an excellent example of a relation. And in that x and y of the ordered pair, we define the domain as all the x elements and the range as all the y elements. Now, keep in mind we said it could sometimes be a comma b, so the domain is the first element and the range is the second element. And we'll see examples of them. Now, if you want to write these definitions, that's okay as well. So, find the domain and range of each of the following. Well, these are ordered pairs. So the ones in blue are the domain elements. The ones in green are the range elements. But notice the domain has a 6 and a 6, so that when we write it, we don't repeat any elements that are repeated. And this is the proper way, using braces, in a sense roster notation, to write the domain. And the range, 7, 2, 3, 2, the 2 is repeated, so we only write it once. And here they're giving you that. Okay, again, find the domain and range. The domain, x elements, range, y elements. And you'll be doing some of that. And this is easy so long as you know the definition and what to write it in the proper form. Okay, now when we look at a graph such as this, and we're asked to find the domain and the range of the graph, and I'll write a little bit here too to emphasize, your domain elements are your x elements projected down to the x-axis. So in interval notation, you notice it's starting with a bracket, -1 right there, and going up to a 3. So there's the domain of this graph here, and the range is y elements. So what we do is we project anything out here over to the y-axis now, and notice it's starting then at 0, and it's a bracket because 0 is included, and it goes up to 6, and 6 is included. So for something like this, when we want to plot the domain, or write it in interval notation, we project the graph down to the x-axis for the domain, and over to the y-axis for the range. Let's continue. And they're showing it to us here. All right, now how about this one? Again, they're asking us for domain. So, in a sense, little by little, this line here is going to go out to positive infinity for x values, and out this way to negative infinity for x values. So the interval notation would be from negative infinity to positive infinity for the domain. Now for the range, again, we're going to project this blue lines over to the y-axis here. So it starts there at -2 and goes up to positive infinity. Okay? And for some people it's hard to imagine that this eventually goes out this way. But again, infinity is a concept just going on forever. All right, function. So far we've talked about a relation, mother, son, city, state, x, y. We've talked about domain, the x values, the first value in an ordered pair, the range, y values, the y elements, the second element. Now we're going to define function. And I find the easiest way to define function is that the x element, that is the first element, is only used once in a series of relations. So that's what they're saying. Exactly one corresponding to a range element. Okay, let's see it. So here we see the 2 is used more than once. So this is not a function. Now, here's another kind of example where the first element here is the domain, the second element is the range. Now notice the 2 is used with the 3, and the 2 is used with the square root of 5. So the 2 element is used more than once. That's why it's not a function. All right, look at this one. 1, 3, -2, square root of 2, -1, -4. The x elements are only used once in these relations. So this is a function. And they're showing it here. One line from each of the domain elements. This is a function. Now another test, whenever we have a graph that can be used and helps to identify a function, is what we call the vertical line test. That is, does the vertical line, as you pass it over the face of the graph, only intersect in one place as it goes across the graph? If it only intersects once, it's a function. If it intersects more than once, it's not a function. So let's look at this. So here, this vertical line is this dotted line going over the face of the graph. And then here it only intersects once. But now here it intersects twice. There it intersects twice. So this is not a function. And of course, if we saw the points labeled, we'll see the x elements are repeated. So this is not a function. Now, how about something like this, like a half circle? Well, again, this dotted line, which is the vertical line that's moving over the face of the graph, intersects once. This is a function. We say it passes the vertical line test. Now, how about this sideward parabola? Again, here it would only intersect once, but here twice, here twice, here twice, and they're showing you it's intersecting twice. So a sideward parabola is not a function. It does not pass the vertical line test. All right, how about this one? Again, they're showing at this stage it's passing once, twice, 3 times, intersecting. It's not a function. Now, they're also defining the domain and range. And again, this goes off to negative infinity for x values, and this eventually goes up, and this eventually goes down. So these are the domain and range. Now let me go back because I think we missed it on this one here. Yes. So for domain here, it's starting at -3, and we use a bracket, and it's going to positive infinity for the x values. And for the y values, this will eventually go all the way up and all the way down. So it's all real numbers, or from negative infinity to positive infinity. Okay. I think I went over that too quickly. Okay, now linear functions. This is your slope-intercept form that generally, if it's a line and it's positive or negative slope or horizontal slope, that is a function. The only one that's not a function is the vertical line itself. X equals A would not be a function. It wouldn't pass the vertical line test. Now, generally, all those lines that I just talked about, except for the vertical line, the domain is from negative infinity to positive infinity. All right. How about things that are non-linear? Well, one of the major things we have to consider is that the denominator of any function, any slope-intercept form, where you have a denominator and it's a variable, that value, let's go on and see one, that value that would make this denominator a 0, we can't have that as a value of x. So how do we find out which value is not included in the domain here? And the protocol, the strategy, the modus operandi, MO, is to equate the denominator to 0. And then we solve this equation, x equals 5. So if x were 5, it would make this denominator 0. So how do we write this then as a interval notation answer? Well, again, this part, it would be all real numbers. So we're going from negative infinity up to 5, just before 5. So that would be a parenthesis here, open in a sense, because 5 is not included. And then you're going to have union. And then on the other side, you're going to start with the other side of 5. And then that would go to positive infinity. That would be the domain of this function, where we found out that the x in the denominator cannot be a 5. If it is a 5, it makes our denominator 0. That's undefined. Now, if this were on a graph, and this were the 5, it would be all real numbers going this way, all real numbers going that way. But at the 5, we would have a hollow, because it couldn't be a 5. And that's what this is showing in interval notation. All right, let's go on. And they're showing what we just said. Okay. Now, for the function g of x, and by the way, this is what we call function notation, where we have a letter and then a parenthesis with an x. This is some value of x. So we're going to put the 2 where the x is. So 4 times 2 is 8, plus 5 is 13. We did things like this when we made our t-charts and we were looking for points to graph. And here they're giving you the x value. And you just do the substitution. How about if it's a -1? Well, 4 times -1 is a -4, plus 5 is a 1. And there they're showing it. So, again, some easy stuff, but adding to our repertoire of our dossier of material we need to develop our certification. Now, how about if g is 0? Well, 4 times 0 is 0, so this will be a 5. And there we see it. Now, how about if you have a quadratic function where this is not linear? See, this is not linear because x is to the 2nd power. Well, you're just going to put the 4 where the x is, do the substitution, and x eventually is 6. Now, I don't want to make this too long, and hopefully, you're pausing, seeing how it's done, and if this is a quiz question, again, the answer is 6, but you want to have it in your notes. How about if it's 0? Well, you're going to put a 0 there, that's 0. You put a 0 there, that's 0, and it's 2. So there is our answer. How about a -3? Again, we did something like this earlier in the course when we were just substituting things, and this is going to be a 20. Okay. Now, here, they're asking us, using this graph, to find out what the ordered pair would be. So a suggestion for this is to make a little t-chart here. And go ahead with me and make a t-chart. And you might put there that this is example 8. I think it's a good idea. It helps you to keep this in order. And we're going to have these 3 values here. X is going to be a -4, x is going to be a 2, and x is going to be a -7. So, when it has these values, what would our y be? So let's just do it, -4. So 1, 2, 3, 4, we go up here. So x is -4. Now y is going to be 1, 2, 3, 4, 5, 6. Y is a 6. If x is a 2, 1, 2, we go right here. Y is going to be a -2. How about if x is a -7? 1, 2, 3, 4, 5, 6, 7. We go up here. X is a -7, y is a 1. So not difficult if you have a strategy to do it. And of course your certification will let us know if you are catching on to these things, and you have some practice too. So there they are. Now, again, we're not graphing with a graphing calculator, but the key to a graphing calculator is you have to put it in slope-intercept. You're going to get y equals, transpose that 3x to this side, -3, and you just put this in, hit graph, and this is the graph. It's very nice. And you can see where it crosses the y-axis here, down here, and then the x-axis. Now here, this is going to be a parabola, and it makes a nice parabola, crossing the x-axis there and there. And we're not going into the significance of that at this time. Okay, here's some others that we could do if we had a graphing calculator. And we're skipping that. Now here are some practice problems. We're just a little over 20 minutes, which is what I wanted to keep it to. And these are the answers. And again, you could pause, rewind as needed. So we've finished now Chapter 6. We'll be doing lots of work in lab and having our test on Chapter 6 soon.